Hey guys, my name is Arun Tyagi, and today I'm going to discuss about high-level design of services products like YouTube and Netflix, where people can upload videos and people can stream videos, and that too on different devices, website, mobile, TV, and all those. Okay, so let's just start with functional requirement and then move ahead to the design. So functional requirement, the obvious ones are that people should be able to upload video, right? People should be able to stream video, means when we are watching, we should be able to stream the video. Then people should be able to like, unlike, comment on the videos like we do. People should be able to search content, right? With the name, with the description of the video or something, content inside the video itself, which might not be in the title and tags, but still people should be able to search based on the content. Then basically people should be able to see the, you can say, the home page, where name, a thumbnail, and in fact a video which they can see on those thumbnails also. So that listing should also be part of this. So these are the basic functional requirement which we will try to cover in today's discussion. Then moving ahead on non-functional requirement, it has to be high performance. By high performance I mean is basically you are uploading content which is you can say very bigger in size, especially these days when your video is starting from 15 GB, right, and going up to 80 GB. So sizes are growing because of the quality of video is improving. So on those, it should not be like that upload itself is taking the entire day. So that should be very fast and very optimized. Then a high performance in terms of streaming also, right? So especially when you are watching a video on low bandwidth internet and watching a video on mobile, then you're watching a video on TV. So requirement is very wide. You can say the range is very wide. So we should be able to optimize is as such that user first is having high quality content, right? And then second, they should be able to, it should not be like that there is a lot of buffering, right? So that way it should be, the latency should be very low, the streaming should be very fast. Then availability have to be high. By availability we mean is basically it should not be like if some of the system, some of the services in the system are failing somewhere, that's just then entire system should not go down. So we should be ready with the failovers. Then scalability, scalability is a factor, especially think of from the perspective that um, let's suppose on a Saturday evening or a Friday evening there is going to be a spike, right? And there are spikes. So it should not be like when there are spike, then you can say your database is becoming a bottleneck, right? Or your computation become a bottleneck. So think from those perspective. We'll think from those perspective that if suddenly there is spike, all individual components of our design should be able to handle that, right? So there are chances that in general that only 5 GB content per minute is getting uploaded on YouTube, but suddenly on a Sunday afternoon 80% of the YouTuber are trying to upload. So it should not be like they're either the temporary, either the storage where they dump raw videos, that is getting bottlenecked because it is unable to handle that much of data suddenly, or upload servers are so busy that they are not taking the request. So we have to think of scalability from that perspective. Then last is reliability. If we are uploading something, that should be available. It should not be like after 1 year or whatever time basically we are claiming, that content should be there for that time period, right? So that way we'll think of reliability, how we will store even when videos are not so popular. Then also, as per the whatever we will declare, as per our declaration, that content should be there. So let's first discuss about some numbers before we jump into the design. So YouTube is having 1.5 to 2 billion active users. I would say users active, we'll see on daily basis. Then daily active users are 500 million, right? And then think of that average length of a video these days is 10 to 12 minutes, so we are taking 10 minutes for easy calculation. And then one video size is around 1200 MB if it is 10 minutes long. On basis of these calculations, let's think of when every video is getting uploaded, so it means per minute we need around 200 GB to store that much of data, which means we need this much GB to store only 1 day data, right? And this is, we are talking about temporary storage. Then we will do replications and conversions, so that storage number will be bigger, way bigger than this one. Seven number of servers, like we discussed in other designs, is we basically, if we have 500 million active users daily, and if one server can handle 8,000 requests, then how many servers are required, right? So we can calculate that this will come around 62,000 and more than that, approximate, right? So these 62,000 and above number of servers are required to handle uh, these many uh, users, I would say, right? And why 8K? We discussed it in other designs also. This is not a final number, but thinking of that, your CPU bound requests and your memory bound requests. So a normal server can handle around 62 CPU bound requests, 60 CPU bound request, and 16,000 memory bound request, and this number is way big, so I'm just taking half of it, which is 8K, right? These numbers will ultimately crunch, but we can take this for calculation. So we need these many servers. Ultimately, we will, when we are in real system, on basis of the data coming up, we keep on increasing or decreasing our number of servers when the ingress or scale is increasing. Okay, let's start with the design. So YouTube is, again, a very complicated design. So what we will do is we will start with a very high level, or in fact, like I'm saying, very very high level first, and then slowly we'll go deeper into the design. So on a very very high level, how it can be, basically we have two types of users: one who is uploading and one who is viewing, who is streaming the data, right? And you also on upload, on systems like YouTube, basically we are recording and uploading videos. On systems like Netflix, basically there are, you can say, movie creators, right, who are big, you can say, who are uploading very very big files, and that too on different languages, right? So there are categories in uploaders also, but let's just think of, there are small files and bigger files. That is how we will try to demonstrate an uploader. Then okay, for both of them, uh, how it will be, you will have a web server. Think of a uploader first. You will have a web server. uh, Obviously there will be a load balancer, so via load balancer you will be connected to a web server. You will send your file to web server. What web server will do is it will pass it to an encoder. What encoder needs to do is, basically, though it will do a lot of work, and I will explain that into next section. But think of, it have to uh, encode the file, it have to transform the file so that it the your video is basically ready for uh, TV, bigger screens. Your video is ready for mobile screens, right, or web screen, or laptop size. So it has to convert it into different sizes, so that it should not be like if a high quality movie got uploaded, then mobile also have to download the entire video and then watch it. So this guy will basically convert that into different sizes so that it is optimized for streaming. And also it will do things like check, tag the video, on basis of the content of the video, not just what user is saying. Maybe user is saying that this is an educational video for kids, but then there is some kind of nudity or some content which you don't want uh, to be watched by the kids, right? So uh, that work also should be done by this encoder, which will tag and then update all the metadata into somewhere into the database. In terms of basically viewing, we are basically thinking of that viewer. For normal things, it will be connected to web server, send the request to web server, fetch, search for videos, and then ask for the links of videos from where it can watch those videos. And ultimately, once you have the link, you will simply connect it to a CDN from where you can stream that video or watch that video, right? And CDN is basically ultimately will have blob in the behind where all the files got dumped by encoder itself, right? Okay. Now before I go forward, also in case of basically uploader, think of it, it is not like that you are uploading everything from your you can say this system to YouTube or Netflix, right? There can be like files are very big, right? If you are uploading a movie, right, there are chances that this is 300 GB, very high quality, very bigger in size. In those cases, normally we expose some storage to those uploaders, and they dump their video there in those systems, and ultimately our system will pick from those places and then do rest of the process like this, right? Okay, now move to just go a little bit deeper into this is still very high level, right? But I tried to expand basically some of the blocks. Okay. Now first let's focus on this database part, right? So what I am trying to show here is because video content especially, right, it is ever growing. Users are still it is not like user are growing as much on daily basis, but videos are growing very fast. Hence the data of metadata of video also will grow. So first is we will have separate databases, so that this is video metadata is not basically becoming a blocker for user service. So that is why user DB and video metadata databases will be separate. Also user is very, you can say, relational in nature. So here we can use SQL, MySQL DB to store this. And in MySQL also this will be a cluster. I'm just trying to show it, though same thing should be there in other designs also, but here I'm putting an emphasis on it just to talk about this part also, that this is a cluster which will ultimately have replication of data for failovers and all those things, and also sharding that can be on basis of regional, that Indian users are sitting in this shard, and or users from US are sitting on that, so that on that basis you can improve the performance of the services, right? So sharding can be on basis of different thing, but what I'm trying to convey here is ultimately behind your cluster you will have replication and sharding. Same for video metadata also, that there will be clusters. Now this data is for me it's not relational in nature. So it can go into NoSQL, and basically for me the queries are going to be simple, but queries are going to be a lot and data is going to be lot. So that is why we can go ahead with Cassandra here, right? So Cassandra will have video metadata, right? And by metadata we mean that a video ID will be there, then maybe link of CDNs, that where it is available, and then different type of tags and all those things will be there, right? So this is this data. Then, like we said that what uploader will do, uploader will upload, connect to a web server and upload their video. Ultimately what web server will do is, what we are uploading is a raw file, right? So we want to upload a high quality video, but YouTube will not keep it as it is, like we discussed earlier, right? So it will optimize it for mobile, optimize it for laptop, optimize it for bigger screens like televisions and all. On those cases, what it will do is, first it will dump it into a temporary file storage, right, which we are using to basically just tell the user that this got uploaded, and it will still take some time because meanwhile we are processing. So if you upload something on YouTube, you should be, you must have seen it, that they are processing different kind of processes is running on your content, but you are not blocked because of that. Just that they took the video and dump it into a temporary storage, and then encoder is working from there. So what encoder will do is, it will take the file from here, right? It will basically receive notification via Kafka. So again, we'll go deeper into it, but here just think of it, as soon as you are dumping, encoder will start its job. It will do multiple jobs, and then because encoder is generating thumbnail, generating tags, so it will upload the video to blob storage, it will upload the thumbnail to thumbnail blob. Think of it as a separate blob. It can be a blob, it can be you know database, because normally database will give you low latency, so it can be a database also, but a database which can store bigger data. So think of a big table here, right? Big table itself is um, one database which is and basically which is optimized for anything which is lesser than 10 MB. But 10 MB itself is a huge size, right? So something of 10 MB in every row you can save here. But just we are going ahead with thumbnail itself, that it will upload it here, and then behind, ultimately in front of that, we have CDN, which is available for viewer to download the video, right? One basically other things which encoder will do is, via obviously something in between Kafka or streaming, Spark streaming, it needs to update video metadata also, because it will identify some tags into the video, so ultimately it will send that entire information into the metadata thing. Okay. Yeah, so we should touch one more thing while we are on YouTube design, um, web servers. So normally we, go with the obvious options, whichever technology we are working on. Normally, and whatever is, you can say, the generic pickups for those, we go ahead with that. But here we have to think of what will be the optimized web server. So basically web servers are normally different from your typical server. A typical server is made for uh, running different kind of services. You can run databases or different softwares and services inside it, whereas web server is basically optimized for HTTP web requests. And so you can think of it is basically optimized for that you have to serve something over the internet, so it has to be extra secure, it needs to be faster, so that multiple concurrent connections are possible in this. So web servers are optimized for that. Even in that, so if I talk about how many popular, what are the popular web servers are there, so I'm sure you might have heard of Nginx. Normally Nginx people use is for reverse proxy. By reverse proxy, think of, people call it load balancing also. People call it reverse proxy, where your end user is basically hitting Nginx server, and ultimately Nginx server is mapping it to one of the server, right? Normally people use Nginx for that, but Nginx is a full-fledged web server, so a lot of people use it for web server also, right? Other than Nginx, we have Apache HTTP server, right? And if you are working in Microsoft technologies, like me, if you are working on .NET, and by now you are on .NET Core for sure, so by default we go ahead with Kestrel. So it is like a fast web server. You can say it is a fast web server. Whenever you are working on .NET Core, most probably you are working on your application is running on Kestrel. Earlier we were used to of Microsoft IIS, right? So I'm sure you might have heard of these names. So these are generic web server which are optimized for fast web serving, concurrent, lots of concurrent connections, extra security, but these are general purpose, right? So they can serve video, they can serve files, they can serve normal content from in memory, and very fast. Here, when we are choosing for something like which is like very heavy files like videos, right, upload and download, we have to be think of specifics that what can help us here to optimized for video itself. So teams like YouTube or Google, they build their own web servers. But to start with, even if we are using Apache web server, there also we have to set mode. So there are modes available where you can set mode for you know video upload mode, if I'm not wrong. In Apache, basically we have mode upload, to be specific. Yeah. So mode underscore upload is basically available there. So likewise, in Nginx also there will be different modes. So if you are choosing a web server, and if your requirement is not generic, like just serving some data over HTTP calls, because here it's very specific, you are serving heavy files, then check for those things also, that can I change some mode so that this is optimized for this kind of content. I wanted to basically touch this area also. Okay, let's just expand our encoder. All right, let's talk about this. So first of all, what is encoding? Uh, this comes with two things. One is basically the type, you can say transformation of the video to different types, and one is also breaking it into small part. So first let's talk about the type. So in video, you might have heard of that, we have type HDR, we have MPEG, which is very famous, and VP9 is for very high definition things which are used for bigger screen, 4K and all those things will come here. So first thing, in your raw video you will have things like video, you will have audio and script. And especially if you think of Netflix platform, where you will have different even in a video you have dubbed in Hindi, dubbed in different regional languages, right? And then you will also have scripts, and that too scripts can also be in different languages. So you have to your in a raw video you can have scripts in a file in English, you can have a script, a file in Hindi, and ultimately you will serve this to your client to render it from these files. Then same with the audio, you can see that you have a viewer is having option of change the setting that I want to listen the Dolby 5.1, and that too in a Hindi or English, right? So there are options. Same, um, there are options like 2.0 and other, and all of them are having different kind of kbps. So you can choose it for yourself, and by default on platform like YouTube, they come with default settings, and on basis of the performance or bandwidth on your side, they keep changing it when you are watching the video, right, on users behalf. Same for video. So there are different kind of these encoding which an encoder needs to do. So when you are uploading a raw video, it will convert it into all these types, because an MPEG may be best for when you are watching it for on a laptop screen or a medium size screen. A VP9 will be this encoder will be encoding will be used when you are watching it in a 4K or a very big screen, right? Same for mobile, maybe this encoding is best, right? So that is why it will transform in various encoder. Now, how this encoder will work: once your file is uploaded to the temporary storage, uploader is received the message that we are processing the video and you are not blocked on it. It will send you notifications once the entire process is done. What encoder will do is, first it will break it into small chunks, right? And those are chunks can be on basis of time. So a video can be a very bigger video can be broken into 10 seconds, or 10 seconds is very small actually. 1 minute chunk or 30 seconds chunk, let's take a 30-second chunk, right? 30 seconds, small chunks, it will be broken. After that, you will do a tagging on it, right? So that you can check that inside this 30 seconds what the content is, right? Content might be so like here in this specific video, I will give tags like uh, high level system design of YouTube, high level system design of Netflix. But in one of the 30-second, I might be talking about web servers, right? So then YouTube will give it a tag of web server also. And when it is giving tagging via Spark streaming, it will keep pumping those to sh service. And ultimately, or in fact, once that entire process is done, what it will give is it will pick top 10 or top 20, whatever our configuration is, top 20 tags, and serve it to the sh service that this video belong is having these many tags. And ultimately, in metadata with your video ID, let's say, you will have these tags listed, and then you will have URL that on this CD and this link the video is available, or in this blog the video is available. That way it will set into this your video metadata database. Once tagging is done, before you upload, like we said, that it will transform. So a transform service will be here, which will transform those small chunks which you created into different encodings, MPEG, VP9, all those. So it will do chunk here and dump them into your storage. Then finally your CDN uploader will pick those chunks and upload them to CDN. This is basically active uploading. There will be a passive uploading also when user are trying to view it. If that is not available, for example, a movie got uploaded and suddenly it became, and it is available on CDN in US, right? Now suddenly it got popularity and people all over the world is watching it. So if a lot of requests are coming from India, then it will be uploaded to Indian CDN, right? Or whichever is near to Indian region. So it will be uploaded to that. That will be a passive uploading. Active uploading, when we upfront is uploading it to that particular CDN. So uploader will CDN uploader will do that. And also how these small chunks are helping us, because on players like YouTube or Netflix, users are directly jumping to the middle of the video, for example, jumping to 45 minutes, right? In that case, it will not download the entire video. What it will do is, first it will download this particular chunk on whichever time wherever you jumped, and when you start watching it, what it will do is it will start downloading the subsequent chunks of it when you are watching it. If you jump from here to here back again, then it will download that chunk, right? And because that chunk is very small, so size of the file is also small and you will be able to serve very fast. So that is what that encoder will do. And this is the main job of heavy job which is happening when you are uploading a video. Okay, one more thing I should talk about before I move to the viewer side is basically for very famous and heavy files, like if you are uploading you can say Avengers movie, you know upfront that a lot of requests will come for it. And to save the bandwidth of your server, to save the computation, what you uh, what actually they are doing is, even before YouTube, let's see if this is YouTube cloud, right? And all the services, you can say your web server, your blob storage, your different kind of services are available here. Before you hit YouTube cloud, right, there can be an IXP server, right, which is more near to your ISP, your internet service provider. Now these servers, on behalf of YouTube, you are giving it to, you can say, your ISP. So your IXP server is sitting before your YouTube cloud, and it is near to ISP. So when a request is coming to your ISP provider, it can serve the file directly from this IXPs, right? Netflix already started this, where all the videos got uploaded to that IXP server, and that is basically helping, you can say, powering your CDNs. So file is available on the CDN, so whenever a request is coming, it is not even hitting your you know your system. So that way you will be able to save a lot of computation, lot of money, when you are when you know that these files are going to be very famous, and these files are anyway heavy, so you can use this technology also. All right, now let's jump to on streaming side, viewer side, basically how they request to view a video and how they are getting served. So there are going to be a lot of things on this side. Let's talk about them one by one. First is, we'll talk about the home screen, but first is the search. When you are basically searching something on YouTube search bar, so there will be a search service behind the load balancer. This search service will be powered by Elasticsearch, all right, because that is uh, still the best solution when you are talking about search where user is typing and they can do typos, right? They do not have exact you can say words which might be saved into your database for that particular video. So Elasticsearch will help there. Then what will happen is, when user click or go to YouTube, they are homepage renders. Homepage is normally having some suggestions for you, and that is basically with the help of analytics service, that homepage is curated for all the users. So this will be very similar to what we discussed in Twitter, for example, that what all things to be shown to users. So as soon as whenever you are streaming any content, what analytics service will do is it will keep on checking what kind of content you are viewing and what are all subscription you are having. It will keep pumping that into Kafka, and ultimately on based of event for a user, that um, you can say a final list will always be prepared, and it will be saved into database or cache. So as soon as you are hitting the landing page, the home screen will basically, first it will get user info from user service, and then it will hit the cache directly. Think of it as a Redis cache, which is having data for all the having data for all the users, and it will serve all the data from here. It's just that when you are viewing it, a backend service will keep improving that. Might be what we are showing to the user, he's never watching those videos, so that will be keep updated. And it is very similar to twitters and all those. Again, in that also you will have hot paths, and where something which is very famous, which you might not be viewing right now, but we know as soon as we will show it to you on your home page, you will there are high chances that you will click on it. So whenever something like that is coming, we will end up adding that to a user's homepage data. Then another thing we need is user service, which is common in almost all the designs, where info of the user will be served. So that will be hitting, even a client will hit to get users info on basis of the token or whatever headers he shared after login. uh, Also it will be used by other services like your analytics service, your homepage service, and all the services. Whoever needs user info, they will hit this service to get the user info. Now user service is basically going to leverage your SQL database, like we discussed earlier. MySQL cluster can be there to basically fetch all the users info. And for fast serve, obviously we can have a cache in between. So here a distributed redis cache is will do a perfect job. Then analytics service, like we discussed, as you are watching things, as you are jumping into things, that entire data is keep flowing from your device to the backend, and analytics service is keep receiving that data and writing it to Kafka. Now behind it there can be machine learning models to see the pattern, what user is basically viewing, where his interests are. Then it will write back things into Kafka, and from where your analytics service will pick the data and ultimately write that into users homepage, or you can say recommendation database, right? So your analytics service will do that. Then one important thing here is that who will give us info about the assets. By assets means, let's suppose we searched a video, now we clicked on that video. So basically what you are doing is you are sending a ID to the backend that I want to watch this video. Asset service is actually having info of the entire you can say the metadata of the video, plus the links of the CDN which are optimized for this user. So think of that this asset service will leverage something called um, user device info, which can give me location of the user, right? And device info, whether it's a mobile, television, or web, for example, size of this thing, and bandwidth and all those things. On basis of this input, asset service will ultimately return the link of CDN, or blob storage, where that file is stored. And it will start once it will give us that, we will end up downloading the chunks from that particular path, right? So overall this is how we will be able to serve these videos faster to the user. Now, like we discussed earlier, there will be master CDN and there will be regional CDNs. So that and it's not necessary that you store everything into all the CDNs. So it's not like whatever is there into master CDN have to be copied into regional CDNs. There are chances that a master CDN, let's call it a master CDN which is in US, for example, right? So like we discussed earlier, that if it is having, for Avengers, if it is having a VP 9 encoding of file and all chunks of it, then maybe here we will upload MPEG, right, in regional CDN for Indian region, because maybe requests are coming from mobile mainly, right? So that way we'll copy that part here so that it can be served faster for mobile users. All right, let's evaluate our design. So basically we claimed, that with this design we will be able to achieve these, you can say, user experiences or non-functional requirements, right? So let's see if we are able to cover all of them. So first is high performance. Like we said that basically we will upload all the videos into your CDN, and that to a regional CDN also, like we discussed here. That way the latency is very optimized. And also we talked about one more thing, that there will be ISP, IXP servers, which is near to your ISPs, and you can think of it as a geographical, caching, which you are doing for a very high demanding videos, and that way you are not even hitting your cloud. You are directly serving the files from nearest uh, uh, your ISP servers itself, you can say, right, in those terms. So that way your latency is as minimum as possible here. So your performance is going to be very high. Next is availability, because let's talk about scalability first. So how we are achieving scalability, like in all other designs, all the services we have taken, all of them can be horizontally scale, right? So you can have, as your users or number of requests or ingress is growing for that particular service, you can basically have multiple, you can say multiple you can increase the number of instances of it, and you can have further regional load balancers, and increase those regional load balancers in front of the service, and then you will have global load balancer for those service. That way you will be able to distribute the load which is growing. So that way all those, you can say, services can handle when your user request or ingress is growing. When it comes to database, because we know that video metadata was growing, that is why we took something like Cassandra, which can serve, which can still perform better when you are having billions of record, right? And in this also further you can do, you can say, you can do sharding on it. You can divide the data in based on different, you can say, categories. Like maybe it can be based on the time of upload of videos, that all the videos of this year are going to this Cassandra cluster, and videos after this year are going there, or maybe it can be on regional basis. Same way, having said that, that is why basically you can say scale is not going to be a problem, because we can scale all individual components in our design. Same for your reliability also, because if you see it from data side also, you are having replication. So even if some of your data stores died, you always have copy redundancy, is basically what we are using here to make it available, right? So you available, and also you can say reliable also, that even if something is dying, there are always copies of it, so you can recover the data from there, and you will create further copies of it, so that even if that died, so you have the copy. So we are making sure that availability and reliability also is taken care. So that way we are covering all the checkpoints, so hence our user experience will be high class with this kind of design. That's it. Thank you very much.